Assalamualaikum and hi to my viewers and Dr. Ika, Dr. C and Dr. Jeff. My name is NURDAYANA FAQIHAH binti. Today I would like to explain about importing dataset. These are the coding and a few packages that we use, which is Pandas, NumPy, Matplot, Statistic and IO. The dataset given by our lecture, and we choose 4 variables, which is brand, KPL, horsepower and weight.
My name is SYARWANI binti Cimai. My metric number is S21203X. I talk about data description. Variable is characteristic or condition that can change or take on different value. There are two kinds of variables: qualitative variable and quantitative variable. Qualitative variable in categorical reference to a classification name according to some characteristic and is normal classification using code number. There are two types of quantitative data: discrete and brand of car. First, variable KPL travel distance. KPL is a continuous variable given that its many accept any number within a defined range. This variable about characteristics in range, central tendency, variability, and distribution. Range value for travel distance minimum and maximum. In central tendency, the travel distance using statistics like mean, median, or mode. In variability can be described using metric like standard deviation or variance. Next, horsepower. Horsepower total for the vehicle. This variable is measure of how much power a car engine products. This is characters range, total value, horsepower minimum and maximum. Characteristics central tendency. Total horsepower can be described using statistics like mean, median, or mode. Sum of the capital. Variability. Total horsepower value can be described using metric like standard deviation or variance. Distribution can be used to analyze the distribution of total horsepower. In week for each vehicle, the week of each vehicle is a continuous variable since it may accept any numerical value falling within a specific range. This characteristic in range. Range the week, minimum and maximum value. Central tendency, the normal or central value of week, can be described using metric like mean, median, or mode. Variability, the week value can be described using metric like standard deviation or variance. In distribution, histogram and probability density chart are two tools that can be used to analyze the weak distribution. The last variable is brand. Brand for car. The brand variable is a categorical variable since there is no interested numeric order and each category or label of discrete. The variable represents the brand name of each car, such as Honda, Mercedes, Ford, and so on.
My name is PUTRI NURDAYANA BATRISYA binti HASBI S212B0035.
3.0 Descriptive measures. KPL is a numerical variable. This is because the variable of KPL have the digit number such as 12, 13, 14 and so on. The variable horsepower is a numerical. This is because the value of horsepower are number, which is a numerically based variable. The value of variable have the digit number such as 4.603, 4.604 and so on. And last, the brand is example of category variable. The car brand have classification names such as Honda, Ford and Alps. Next, 3.1 Measure of frequency. We have three code frequency. Firstly, code frequency for brand. This is the code for show the brand graph, and the output show the graph. From that graph we can see the Honda car brand is the highest among all brands, and the least is Audi car brand. Secondly, code frequency for KPL. This is the code that show the graph KPL. The output show 13 km is the travel distance that is most frequently used. Thirdly, code frequency for horsepower. Run the code and the output show the graph. From that, 1.5 horsepower is used more frequently than the others. Last, code frequency for weight. This the code and the output show that 1.985 kg is the most popular weight. Okay, move on to the next slide. 3.2 central tendency. Firstly, measure central tendency of KPL. This is the code to find central tendency. Run the code. The output will show the mean, median, and mode for KPL. Secondly, measure central tendency of horsepower. The code show how to find central tendency. The output show the mean, median, and mode for horsepower. Last, measures of central tendency of weight. This is the code and output show the mean, median, and mode for weight. Okay, let's go to the next topic, which is a measure of position. Firstly, create code to measure position of KPL and the output will show the quartiles. Secondly, create code to measure position of horsepower. Run the code, the output will show the quartiles of horsepower. Last, create code to measure position of weight and run the code, the output will show quartiles of weight. Next, slide about measure of variation. Okay, create the code to measure variation of KPL. Run the code and the output show range, variance, standard deviation, and COV. Secondly, measure variation of horsepower. This is the code and the output will show range, variance, standard deviation, and COV. Last, measures variation of weight. This is the code to find variation and the output will show range, variance, standard deviation, and COV for variation of weight.
My name is NURDAYANA Putri binti HAIZAD. My number BATRISYA is S22B009. Okay, I will continue explanation about data visualization. Okay, based on our project. Okay, first data we take about the brand and the KPL. Okay, first we print brand with KPL by chart. We make the title for the header chart. Okay, the brand column is used to aggregate the data and the KPL value for each brand are added up to produce the variable brand with KPL. Okay, using PLT subplot, the code generate a fresh figure and exists for object. The variable fits and aids the given and aids the figure respectively. The X bar function to create a bar chart with orange color x-axis and y-axis value from the brand with the KPL data frame. The chart title and the label are set using the parametric title, the label, and y label. Okay, from the result and to display the chart, we call the PLT show. The result that we record based on the bar chart, the output brand is highest is measuring the total distance in kilometers that a vehicle can travel with 1 liter of the fuel compared to the other car brands. Okay, for the second chart, we use the KPL with the horsepower. Okay, we print the KPL with horsepower bar for the header of the chart. Okay, the horsepower column is used to aggregate the data and the KPL value and are added for each horsepower number to generate the variable horse with KPL. Okay, for the using the subplot, a new figure and axis object are produced. The variable fig and x are given to x and the figure respectively. X bar to create the bar chart with x-axis and y from the horsepower with KPL data frame. Y-axis we use the value from the KPL column. Okay, to display the bar chart, we call the PLT show to display the bar chart about the KPL and horsepower. Okay, the result that we got based on the bar chart, the horsepower on 0.9 is the highest in measuring the total of the power or rate at which work is done. It has a high output of the engine or motors of the vehicle compared to the other cars. The lower horsepower, we have the greater the KPL data. Okay, the third bar chart, we use the KPL with the week data. Okay, the header we display the KPL with the week bar chart. The weight column is used to aggregate the data and the KPL value for each added to produce the variable. Okay, for the use, we use the subplot to the codes to generate a fresh figure and axis object, the variable fig and x are given the x and the figure respectively. Okay, the X bar function to create a bar chart with the colors, and we use the x-axis and y-axis value from the week with the KPL data frames. To display the bar chart, we call the 2plt.show, and the result that we got is based on the bar chart. The weight of 1.985 is the higher weight to compare the other vehicles. So the conclusion on this chart, the lower weight has the higher KPL. As a chart in our project, we use the data from the hours power data and weight data. With a header, we display the horsepower with weight bar chart as a header for the chart. And the weight column is used to aggregate data, and the KPI value for each brand are added up to produce the variable brands with KPI. Okay, subplot we use the code to generate the fresh figure and axis of object, same as before. Okay, and SBAR function to create a bar chart with the colors and use the display the x-axis and y-axis value from the brand with KPI data frame. To display the bar chart, we call to BAT.show. Inside the record is based on the bar chart is the weight of 4.464 is the highest weight with 3.25 horsepower. So the conclusion that we can make based on the chart is the highest weight has the higher horsepower.
My name is HAFIZAH binti HASSAN and my trade number is S22B0007. I want to present about statistic inference. Statistic inference have three methods. First method is hypothesis testing. For hypothesis testing, we test about two brands is BMW and Ford of different weight. And this is a Python program and output to implement brand sample t-test on the two dependent sample. We get the mean value, standard deviation, p-value, t-test, and the hypothesis. The result of hypothesis testing of two samples and test statistics by using Google Colab in Python language, a significant level of 0.02 is used to test this claim. For H0, we get the sum weight of BMW and Ford car, and H1 is different weight of BMW and Ford car. Significant level alpha is 0.02 and t-test is 4.682, and decision rule we get the critical region is 2.326. The decision, the t-test more than critical region. We reject the H0 hypothesis if the value of t-test falls within the rejection area. We can conclude that we have strong evidence that the weight of BMW and Ford car is not equal to the weight of cars. Second method is correlation analysis. For this correlation analysis, we measure the relation between the weight of BMW and the horsepower of BMW cars. The sample size of 93, we use Pearson technique to calculate a correlation coefficient since both data are ratio type. In this is a code and output of result, Pearson's and Spearman correlation. We get scatter plot of weight of BMW car against horsepower of BMW cars. We decide to test whether there is any evidence of a linear relationship between the horsepower of BMW car and weight of BMW car at the 0.05 level of significance. The Pearson correlation, we get null hypothesis is there is no correlation between horsepower and weight car BMW. For H1, there is a positive correlation between horsepower and weight car BMW. The alpha is 0.05 and degree of freedom is 91 and test statistic is 7.5995. Confidence interval of the correlation coefficient at 95%. Conclusion, since the p-value is 2.599, negative 11 is less than the significant level of 0.05, so we reject the null hypothesis. There is sufficient evidence of a linear relationship between the horsepower and weight of BMW cars at the 0.05 significant level. The third method is prediction modeling. In prediction modeling, we choose the linear regression. And this is a code program and output to calculate linear regression. Horsepower and weight are included in the model. The R-square value is 0.068, which means 6.8% of the variation in KPI can be explained by horsepower and weight. From the formula, we get the X1 is horsepower of BMW car is negative 0.1165 and X2 is weight of BMW car is negative 0.4794. We get the positive value of KPL of BMW cars. We get the coefficient of determination R square is 0.065. Since 0 more than R square more than 1, it shows the weaker linear relationship between KPL with horsepower and weights. The two results, we get the same conclusion. This is we reject the null hypothesis because there is sufficient evidence that the horsepower and the weight of BMW car affect the KPL of BMW cars.
My name is IKRAM, bin ROSDI. My magic number is the S21A0064. Last part in this project, which is conclusion. This project explores various aspects related to the topic and make important findings in section 1 to 5. The project sets the stage by highlighting the problem statement, highlighting the need for research, and defining the scope and purpose. The literature review helps identify gaps in knowledge and build on exciting research. The result analysis section presents the data collected, performing statistic analysis, visualization, and interpretation. The discussion section contextualizes the findings, compares them with existing literature, and discusses their implication. The findings shed light on important aspects related to the topic and provide a solid foundation for further research. The insight gained from this study can be applied practically to deal with the research problem effectively. Overall, this project has added to the body of knowledge and opened up space for the future exploration in this area. Thank you.